in this lesson we're going to be studying logarithms, and we're going to start by learning the laws and theories of logarithms. So the first law states that log b of mn is equal to log b m plus log b n. So what this means is that log of a number multiplying each other can be expressed as log b of the first number plus log b of the second number. So for example, if I have log 2 of 10, now this 10 can be written as 2 times 5. Alright, so this 2 times 5 can be m, and then this can be n. So we're going to express that 2 times 5 in logarithm form. So it's going to be equal to log 2 of 2 then plus log 2 of 5. So because 2 times 5 is equal to 10. So don't worry about the simplification. We'll do that later on in the video. So the second law states that log b m over n can be written as log b m minus log b n. So if I have log 2, let's say 7 over 2, alright, this can be written as log 2 7 minus log 2 2. And then the inverse, like if you want to write it from this form to this form, for example, you have log 2 3 minus log 2 4. So this can also be written like backwards, can be written as log of 2 3 over 4. Alright, same thing is applicable to this one, the first law. This can also be taken back to the initial form of log 2 into 10. You're going to say 2 times 5, which is going to give you 10. Alright, so let me wipe the screen. Let's go to and see the third law of the logarithm. So let's discuss the third law of logarithm. So the third law of logarithm states that log of b n to the power of k can be written as, now we are going to take this k back to this log bn, and then it will form the coefficients of the log. So this is k log b n. Alright, so for example, if I have log 10 of 100, now this log 10 of 100 can be expressed as log 10 raised to power 2, that is 10 square, which this is in this form. Okay, so we now write it as this 2 is going to be taken in front of this log, is going to be 2 log 10 10. Again, don't worry about the simplification, we will do that when we start solving questions. So let's discuss special cases. In special cases, number 1, we have that log bb is equal to 1. So it means that any logarithm to its base is equals to 1. So any logarithm b to the same base, its base, is equal to 1. For example, log base 2 of 2 is equal to 1. Log 3 to base 3 is equal to 1. Log 10 is equal to 1. Log 7 to base 7 is equal to 1. Alright, that's the concept of these special cases of number 1. Alright, so let's look at number 2, the special case. So for number 2, talking about the special case, we have that log b of 1 is equal to 0. So it means that logarithm of 1 to any base is equal to 0. And how did it come about? Assuming we have log b, this one is the same thing as b raised to the power 0. Alright, for example, 2 raised to the power 0 is equal to 1. Any number raised to the power 0 is equal to 1. So b raised to the power 0 is equal to 1. And then from the one we discussed last on special cases, we will take this 0 to the front of this log so that it's going to be equal to 0 log b of b, which is equal to 0 multiplying any number is equal to 0. So that's why log of any base to 1 is equal to 0. So having discussed all these laws, let's go ahead and solve some examples. So the first example we're going to solve is this. We're going to evaluate log base 2 over 3 into 4 over 9. So solution, we have log 2 base 2 over 3 into 4 over 9. Now this 4 over 9 can be written as 2 over 3 all square. Alright, because 2 square is equal to 4 and 3 square is equal to 9. So I'm going to write this as equal to log base 2 over 3 into 2 over 3 all squared. Now we are going to move this 2 to the front of this logarithm so that it will be 2 log base 2 over 3 into 2 over 3. Alright, but recall that log 2 is equal to 1, and then log bb is equal to 1. That is, any logarithm to its base is equal to 1. So let's go ahead and finish the simplification. So this is now equal to 2 multiplied by log 2 over 3 to 2 over 3 is equal to 1. So 2 times 1 is equal to 2. So let's solve the second example. So it states evaluate using table log 1.44 minus log 90, then plus log 0.0625. Alright, so solution, we have, it's going to be log of, now we have log 1.44 minus log 90 plus log 0.0625. So from the first law we discussed, we have that log 2 times 5 is equal to log 2 plus log 5. Alright, so this log 2 plus log 5 can be this log 1.44 plus log 0.0625. So we are going to take this log 1.44 plus log 0.025 back to this format. So what we're going to do here is to multiply 1.44 and 0.0625. So we have log 1.44 times 0.0625, and then we're going to divide it by 90, because this is negative sign. Negative sign is associated with division. Positive sign is associated with multiplication. So by the time you perform this with your calculator, we're going to get log of 0.001. And then this can be simplified as log of 10 raised to the power negative 3. Alright, because this 0.001 can be written as, this is 0.001 over 1000. That is going to convert it to fraction. So it's now going to be 1 over 1000, and then 1 over 1000 is the same thing as 10 raised to the power negative 3. Alright, so remember, any logarithm without any base is assumed to be base 10. So this is going to be equals to log base 10 of 10 raised to the power negative 3. So we are going to move this negative 3 in front of this logarithm so that it becomes negative 3 log 10 10. and then log 10 is equal to 1. Our answer now becomes -3. Alright, so let's solve another example for easier assimilation. So let's solve question number 3. We are going to simplify log base 2 of 27/4 minus log base 2 of 9/8 plus log 2 of 1/24. Solution. So this is, now if you look at this, you find that all of them has the same base. So this is log 2 into, now plus is associated with multiplication, negative sign is associated with division. So we're going to multiply 27/4 with 1/24 and then divide everything by 9/8. So let's start. This is going to be 27/4 multiplied by 1/24, then divided by 1/8. So this is 9/8, not 1. So this becomes log base 2 of 27/4 times 1/24. Now we're going to take the multiplicative inverse of this to change it to multiplication. This becomes 8/9. So this becomes log base 2 of, now 3 into this 27 is going to give us 9. 3 into this 24 is going to give us 8, because 3 times 8 is 24. Then this 9, you cancel this 9, and then this 8 is going to cancel this 8. So we're going to be left with 1/4. Now this is the only one that's remaining here, and then this is the only number that's remaining here. Remember, when this 9 cancels, it becomes 1 times this one here now. So it's only 4 that's the number that's remaining at the denominator. So this is now equals to log 2 into, now 1/4 can be written as 4 raised to the power -1. Alright, so this becomes log 2 into, now this 4 can be written as 2 raised to the power 2. So we have 2 raised to the power 2 into -1. So this becomes log 2 into, we are going to multiply these 2 and -1. So if you do that, we are going to have 2 into -2. Alright, and then by the virtue of special cases of logarithm, we are going to take this -2 in front of this log because it's an exponent. So we have that -2 into log 2 of 2. And then from our special cases, we have that log of any number to its base is equal to 1. So our final answer becomes -2 times 1, which will give us -2. So this is the answer for this question. So let's solve the last example we have. This should be our fourth example. So we're asked to simplify log 2 of 4 plus log 4 2 minus log base 25 of 5. Okay, so solution, we have log base 2 of 4 plus log 4 base 4. Now these two can be written as 4 raised to the power half, because we know that square root of 4 is the same thing as 4 raised to the power half, and square root of 4 is equal to 2. Alright, so writing 2 as 4 raised to the power half did not change anything, and we did that so that we can have the same base. Okay, you see that here is base 4, we need to have the same number here so that we can convert it to 1. So that's why I didn't go ahead to perform the normal 4 times 5 divided by 2. And so this one can be written as negative log 25. Now this 5 is the same thing as 25 raised to the power half. Okay, because we know that 25 raised to the power half is the same thing as square root of 25, which is equal to 5. So writing 5 as 25 raised to the power half, you see the same thing. We did not change anything. And so like this, we can now simplify it by writing it as log 2. Now 4 can be written as 2 raised to the power 2, then plus log 4 raised to the power half, minus log 25 raised to the power half. So this becomes, I'm going to take these 2 in front here, take this half in the front here, take this half in the front here, so that we have 2 log base 2 to 2 plus half log 4 base 4 minus half log 25 base 25. And so this becomes 2 times, now log 2 is equal to 1 plus half log 4 base 4 is equal to 1 minus half log 25 base 25 is equal to 1. Let me make space here. So this becomes 2 times 1 plus half times 1 minus half times 1. 2 times 1 is 2 plus half times 1 is half minus half times 1 is half. And then we know that half minus half is equal to 0. So we now have 2 plus 0, which is equal to 2. So thank you for watching. Please remember to subscribe to my YouTube channel, like, share and comment.